All right, we shall begin. I forgot. Last, I was so excited to tell you about grades in life and whatever. I didn't actually cover the entire lecture, which let's see. The last few slides talked about. So you're gonna have to kind of review this a little bit on your own. Oh, GitHub won't even load it. Let me see if I can get this up in here. The last few slides just had a little bit of information about running shell, okay? And now I assigned some homework in DataCamp about using shell, which is basically your terminal. And yes, it is different if you're on Windows or a Mac. I teach from a Windows computer, but I'm also familiar with kind of Unix and Mac systems. There's a lot of similarities. Certain things are different. Some of the function names are different. But the idea of like navigating your directory, changing directories, creating directories and things like that, those apply. So make sure you are familiar with shell or just working with a terminal. So on Mac OS, you'll just kind of open up terminal. You probably have Launchpad, or you can just open up Spotlight, Command Space, and if you just type in terminal, it should pop up and you can go straight in there. And if you use Command Space terminal often enough, you can just do Command Space T, and then terminal will be the first hit. And then that's like the fastest way to open up terminal then, right? You just Command Space T, enter, and then and it should go, okay? Or add it to your dock, okay? On Windows, you'll want to open up Anaconda PowerShell prompt. So I guess this is under the assumption that you've installed Anaconda. So I guess I didn't talk about Anaconda. What is Anaconda? Oh, look, okay. It used to be the first hit when you search for Anaconda would be either it was like a music video. But now it's what it should be, which is the Anaconda distribution. Anaconda distribution includes Python and a bunch of basic packages necessary for data science. And it includes, and it's called Anaconda because it's based off of this package management system called Conda. There's one of the things about Python is there's a whole bunch of packages that have to kind of play together nicely. And what often happens is somebody will update their package, and after they update their package, these other packages are no longer compatible with that package. And so you have all of these dependencies, and Conda is kind of this package management system that says, over here we've got version 2.63, and over here we got version 3.1, and 3.1 likes version 2.61, but not 2.63. And so if we want to run this, we're going to load this package and that package. It takes care of all of that for you, so you don't have to worry about it. So that's Conda, and then I guess Anaconda is just kind of a play on that. And it does it. So anyway, you'll install Anaconda whether you're on Mac or PC, and then once you get that going, you can load it up using PowerShell prompt, and then and you can navigate and so on and so forth. Okay, and you can add things and we'll talk more. Today's lecture is going to focus on Git. Okay, I've already assigned a couple chapters from Git on DataCamp as well. So please, work on that. I think it's due just in a few days here. So work through that. Just introduces you to some of the basics of Git. So let's talk about that. What is Git? Git is at its heart a version control system. And what a version control system is that it tracks all of the changes that you commit to. Git uses these folders called repositories, okay? And it tracks all of these changes that you commit, And anytime you need to, you can roll your files back to an older version. Okay, this is especially helpful if you're collaborating with other people. And so if you do get a job at some company that where they do code and stuff, almost certainly they will have some kind of version control system. And I think Git is one of the most widely used version control systems out there. There's other ones out there, but Git's probably one of the most widely used ones. You might have your, own ad hoc version control system on your own computer. I think we've probably experienced this when writing an essay, and you say like, okay, essay final version, and then you go and you make some changes, and you go, okay, final version 2, okay, final version, this is the final version or something, and you create these copies, and if you ever need to go back or something, you have these older files, and Git is basically just a more elegant and smarter version of that, and it allows for different kinds of branching paths in the timeline, I guess. Okay, so you can think of Git as kind of a like this multiverse timeline manager, right? So if you think of your files and different versions of it being like different pathways on this multiverse timeline, how do you jump from one timeline to another, or how do you go back in time? How do you do stuff like that? How do you merge these different timelines and weave them together? That's basically how Git works. The most very basic commands that you need to be familiar with will be, in my opinion, are these ones, okay? Git status. This is probably the most important command. Well, I don't know about the most important one, but this is the one that you'll be using frequently to just kind of check the status of your repository. I recommend running this very frequently. Here I'm in the repository for this class, which I've titled 2024 Spring Stats 21, and it says nothing to commit, working tree clean, your branch is up to date with origin main, and things like that. As you work in your repository, you will be creating files, you'll be modifying files. Okay, and you save them on your computer, but then if you want it to be tracked in the repository, you kind of take these, basically you take little, you create kind of like save points, okay? So if you've ever played a video game, right, and like a big boss is coming up next, what you do is you often create a save point before you're gonna go into battle, and therefore, if like you go into battle and something terrible happens, you can revert back to that save point, okay? Something like that. And so with Git, you do something similar. Let's say you got this code and you're like, okay, I want to try out some experimental feature. I want to try adding some new code, but I'm afraid if I do this, I'm going to break what I've done over here. So what you do is you create a save point. You call this a snapshot. You commit your snapshot here, and then you can create like a branching thing, or you can keep just adding things. And if you need to, you can always kind of revert back, okay? So how do you set up this snapshot? Well, first you add the files that as you like them right now. And you can add your file name.txt, which adds individual files. If you just want to add all of the current changes that exist in my directory, you just do add dot, okay? And that will do everything. And then once you have them added, then you do commit. You do git commit -m and a message that describes the commit that you're creating, this snapshot that you're creating, and that's what how it works. Okay, and so the picture looks kind of like this. You've got your working directory. As you work, you kind of you make changes, you add files, stuff like that. Then you do git add, and this is going to stage the changes you want to the repository. This puts them in the staging area. And once you're happy with the way your staging area looks, you commit those. You do git commit with some kind of description, and that's going to put it into your repository. Git separates these things. Why do I have to have a git add and a git commit? Because you might be like, you know what? I'm working, I've made these changes, I'm happy with the way my directory looks, and I just want to kind of commit that right there, then and there. Why do I have to do git add first and then git commit? Well, the reason why is because the way we work isn't always this nice logical flow, right? When you do commits to a repository, your commits should be small, logical, incremental changes that can be easily understood, okay? But as we work, we often have multiple tabs open, maybe multiple files open, and we might be making multiple changes all at once, okay? If you want to kind of roll things back, you might want to just roll back one file. Like you might have modified 5 files, but you might want to, you might not want to create snapshots of all 5 changes all at once. You might want to say, all right, I've modified 5 files, but I want to be able to kind of roll back each of these files individually, type of thing. Okay, so you might want to create a snapshot at, you know, for just kind of one file, another file, and things like that. And so you can add files separately, commit those changes separately as well. Okay, and all of those changes are tracked in the log, the Git log. Okay, and so if you need to, you can always kind of look at the history of your, I guess, your timeline. And this is all in the Git log, okay? This lists all of the different commits made to the repository. This list can be very, very long. And so if you open up Git log, it'll just show you what fits on the screen. And if you have more things, you have to hit space to get to kind of the next page. To quit the log, you type in Q. Sometimes students get confused and they're like, how do I get out of the log? Just hit Q to quit, okay? And in the log, you can identify which commit, which moment in time has the version of the file you want, right? So this is kind of like, I don't know if you guys are watched Loki or whatever. It's like, you know, you have the timeline and you can kind of like, just imagine you've got this wheel that you can kind of like turn and it's like, you know, this is this moment in time and this is where we want to insert ourselves, all right? And so that's what Git log is. It's not as fancy and it's not as beautiful. It's all just text, but hopefully you've given yourself good descriptions, okay? So if all of your commits have the description made changes, okay, that's terrible and you're not going to be able to figure out like what moment in time you want, right? So you want to give yourself good little descriptions so you can say, oh yes, this is the moment in time I want to return to so I can do whatever it is, right? Once you return to that thing, you can, or once you figure it out, you can say, oh yeah, I want to restore that file from that moment in time, okay? You can use something like git checkout, okay? Git checkout, and then the moment in time uses something called a hash. Okay, the hash will, usually it's like this very long, like 40 character long thing. It's this really long thing. You only have to type in the first few characters, say like A, B, 1, 2, 3, E, F, or whatever. Just the first few, and it will say, oh yeah, that's the moment in time. I want to check out the file. I want to retrieve this particular file from that moment in time. So you can do something like that, okay? You can also, if you're not, you know, if the description isn't enough for you to figure out, oh, is this the exact moment I want to go back to? You can ask something like git show, okay? Git show, you put in the name of the code, the hash there, and it will tell you a little bit more information there. And when you do stuff like that, you'll see stuff like minus, minus, minus A, and this will be file name.txt. This will be what the file looked like before the change, plus, plus, plus B, file name.txt, file after the change, and you'll see stuff like this, minus 23.4 plus 23.5. And this is saying changes begin at line 23. We got rid of, or the output's going to show kind of 4 lines from before the change, and then after the change there's 5 lines, and then it might show actual lines from the file. And I apologize for the tough to read text here, but I think these are the default colors that Git uses which are not colorblind friendly, but you can kind of change the settings here at some point. But basically, if the lines were not changed, they appear in white. If lines appear in red, those lines were deleted. And if lines were added, those lines show up in green. If you change a line, like if you change one word in a line, so it will show you the old version of the line as deleted and the new version of the line as added. Okay, even if you're just changing just one line, okay? It's not necessarily shown up that way. Okay, GitHub, okay? GitHub is a website that uses Git and allows you to store kind of public or remote repositories, okay? So GitHub is not the same thing as Git. Git is kind of the program or application that you use on your computer, this little bit of technology that allows you to kind of travel back and forward in time, okay? A lot of times you want to set up what we call remote repositories, and these are kind of like backup systems, so that if your computer breaks down or gets stolen or something terrible happens to it, you don't just lose all of your work, okay? I think we're all very kind of familiar with cloud computing and stuff now, but in terms of like your email is like always exists in the cloud, okay? And that like you log into a website and you access your email. But if you go back like say 20 years, files and everything was like a very local thing, okay? You would log into an email server and you would download your emails and they disappeared, okay? And if your computer broke, like you spilled water on your computer or something happened to it, like everything was just lost. And you would have to buy these separate machines to back up your computer. You would buy like these tape backups or these disk backups or things like that. Now we have all of this kind of cloud computing stuff, and all of your emails exist on some server, and probably all of your photos are backed up on some, Google Photos or iCloud or something like that. And similarly, if you have files on your computer, you can create a remote repository, which is going to just be a identical version of the files that you have of your local repository. And GitHub is a website that hosts a bunch of these remote repositories. And they have this infrastructure set up so that multiple people can kind of collaborate on the same remote repository. And it facilitates for a lot of kind of open source development and things like that. So it's great. It uses Git. There's a bunch of other websites that do similar things. There's like BitLocker. I don't know. Let me just go to Google here. And I'll just type in GitHub versus, okay, there's GitLab, Bitbucket, GitHub versus GitLab versus Bitbucket. Okay, so these are all kind of like, what are the differences? They're just different companies, okay? GitHub, I think, is now owned by Microsoft, and people were afraid that when Microsoft bought GitHub, they would ruin things, and so far they haven't, okay? So far it's still pretty good, okay? So, so we still very much like GitHub. Oh, okay, let me give you your first view quiz answer before I forget. First answer today is A. A as in apple. A as in apple. What did I write? Okay, so GitHub is a company that hosts remote repositories using Git. It's not required to use GitHub to host your own remote repository. You can set up your own kind of server and host your own remote repositories and stuff if you like don't trust Microsoft and things like that. But GitHub makes it really easy, and it's it's a popular and well-loved site, okay? It is possible to create a repository on your local machine and then push it to GitHub But my recommendation is to create a repository on GitHub and then clone it to your local machine. And I think that's a easier way. Okay, so if you haven't done so, you need to open an account with GitHub, and then you need to create an SSH key. All right, so in order to get your computer to be authorized to write and talk to your GitHub account, you need to have you need to give your computer a key. This is called an SSH key, and this just kind of authorizes your computer to say, hey, I'm going to make changes to this repository, and GitHub says, oh, okay, you are trusted, we're going to let you make changes. And it prevents other people from making changes to someone else's repository as well. Okay, and so once you have that SSH key set up for your account and your computer, you'll create a repository on GitHub and then clone the repository to your machine. Okay, so let's go ahead and try this out. And so I, your professor, have a repository for the class, and this is my GitHub account. Okay, Smiles Chen, and this is me, and you can see all of my repositories. Actually, the one I need to start is 2024 Spring Stats 21. Okay, so this is going to be the repository that we will have. Okay. Meanwhile, I'm going to pretend to be a student. Okay, so I have two terminals open. The one on the left over here represents me, the professor. Okay, and this one over here I've got running on a virtual machine, and this is me trying to pretend to be a student. Okay, so I've also created a GitHub account for me pretending to be a student. This is Miles Chen student. This is a picture of me. I look like I'm 12. I think I'm 21 in this picture, 20 or something like that, right? So this was just my curse of always looking like a child or something. Okay. Anyway, this is me when I was a college student, and I'm going to pretend to be a student here, and so I'm going to show you how to set up a repository here. Okay, so what we need to do first is we need to create an SSH key. So I'm logged into my account, and I click my profile over here, and I'm going to go over here to settings. Okay, I'm going to go to settings, and then over here I'm going to come over to SSH and GPG keys. Can you guys see that? SSH keys. So I'm going to click over to SSH keys. And I need to create an SSH key for my laptop computer, right? I have an SSH key. I guess I've already set one up for my desktop computer at home, but I need to create one for my laptop computer. So I'm gonna, I have to create the SSH key here. So the command is you are going to run this command ssh-keygen-t, right? So here I am. This is my terminal, okay? And I can just kind of say like, okay, where am I? I'm just in my home Miles folder. You might be on your users, whatever folder or something. And I need to generate an SSH key. So I'm going to do ssh-keygen, okay, -t ed 25519. This is the cryptographic algorithm that generates the cryptographic key, -C, and then I'm going to type in the email address. You have to use the email address that you used to create your GitHub account. Okay, so whatever email address you use to create your GitHub account, you have to use that. I think that's mileschen@ucla.edu. So this is going to be I'm going to create my keygen here, my SSH key. So I hit enter, and then it says generating a public-private key pair. Enter the file in which you wish to save. The default is .ssh ID ed 25519. I'm happy with the default, so I'm just going to hit enter. it says I've created the directory.ssh. It says enter a passphrase, empty for no passphrase. I strongly recommend leaving this blank. Do not enter a passphrase here, because if you enter a passphrase, you have to type in your password every single time you do a commit. And it can get very, very, very annoying, okay? So if you have your own computer and your own computer has a login to prevent like random people from using it, I'm gonna recommend not creating a passphrase here because it gets really annoying. So I'm gonna just leave it blank and enter this. I hit enter again, and this is it. Okay, so I have created an SSH key. If you've already done this and you created a passphrase and you're like, oh, I wish I don't have a passphrase, you can just delete the old SSH key that was developed. You just delete the ed255 files, and you'll have that. Okay, so now if I list off what's inside my home directory, okay, I have a folder .ssh, okay? ls-a shows you that your hidden folders, and one of them is .ssh. So I'm going to change directories. I'm going to do cd .ssh. I'm going to change into my SSH folder. And if I type in ls here, it lists off the files. And I have two files. One is id_ed255. This is the SSH key. And then I have id_ed25519.pub. This is the public SSH key. Okay? The public SSH key is what you are going to give to GitHub. So you need the contents, you need to copy the contents of your public SSH key. There's a few ways you can do this. One is you can just cat the contents. You just cat id_255.pub. Okay, make sure you type in .pub. You don't want the private key displayed. You want the public key. And when you hit enter, it's going to look something like this: SSH-ed25519, a string of text, and then it's going to have the email address that you used. Okay, and you can just kind of highlight this and copy it. Okay. Another way is you can open it up using, say, a text editor like Nano. Okay, and I can do nano id.pub, and when you do that, it will open up the text editor here, and you can highlight and copy that. But I think cat is fine. If you're on a Windows machine, cat isn't a command. It's type, type, space the name of the file. That's how you show your SSH key. Okay, so I've copied this thing. I'm going to go back to GitHub. Under SSH keys, I'm going to click new SSH key. Okay, and under the key, I'm going to go ahead and hit paste, and I've copied basically the exact contents, right? SSH.ed25519. Mine starts off with AAAA, and I've got that. I've pasted that here. The title is going to be, give it just the name of the computer you're using. So this will just be laptop, and I'm going to call this virtual machine. I'm going to call this my Surface laptop. Okay, so basically, you know, laptop computer. Just in case you have multiple computers or something, just give it the name of your computer. And this is how you add the SSH key. All right, and so I'm going to click Add SSH. Oh, it's asking me for my password. Okay, and so it says you have successfully added the key Surface Laptop Virtual Machine, and there I go. Okay, and right now it says never used, but that's fine. Okay. All right, so now I've created an SSH key, and here's how you do it. Oh, okay. I guess another way you can do it, if you're on on Mac, you can do clip, and you can just type in id underscore the name of the file, and we'll put it to your clipboard or something like that. This is probably the location there. All right, and so now we have an SSH key set up, and now we should be able to kind of create repositories and clone them. Okay, so I'm going to go back to GitHub, and I'm going to create a new repository. So I'm going to go to repositories. I'm going to click new, and I'm going to create a new repository on GitHub. And I'll just call this demo repo, okay? For my demo repository, this will just be, and my description will be a demonstration repository for stats21. Okay, you don't have to do this, all right? So I will do this. I'm going to add a README file, and I'm going to say, let's create this repository. So I'm going to create this repository. Okay, so this is important. What I want to do is I want to clone this repository to my computer. I need to figure out where I want to clone it to. Okay, I do not want to clone it inside my SSH folder. So make sure you navigate out of there, all right? So you can go to your home folder by doing cd tilde, change directory to home folder, tilde is your home folder. So cd tilde will be here. You can type in pwd. This is my home folder. I'm at home/miles. And I'm going to go ahead and just create this repository in my home folder. Or if you want, you can navigate to say like desktop or cd, I don't know, documents or something, right? You navigate to your thing. This is also why I highly recommend not using spaces in file names and folder names, because as you try to change directories, like you got to like backtick, escape your directory names that have spaces and stuff. Okay, so I'm in my home folder. I want to, I've created a demonstration repository on GitHub, and what I want to do here is I want to clone this. So I'm going to click this little green button that says code. There's a drop down, and it says clone, okay? And there's a few options. I'm going to clone using SSH. So, and this is going to be the address. I'm going to copy this URL to my clipboard here, okay? And I'm going to type in git clone, and I paste in that address, okay? Git at GitHub, Miles Chen student, demo repo.git. Whoops. And then I'm going to go ahead and hit enter. And it says it's cloning the demonstration repository. And this is the very first time I'm using the SSH key. So it asks me this question, and it says, the authenticity can't be established. The fingerprint is this. Are you sure you want to continue? I'm going to go ahead and just type in yes. I'm assuming that my connection to GitHub is good. Okay. So we're going to permanently add GitHub as a list of known hosts. And I type in yes, and now it has cloned the repository. Okay, so if I type in ls now, we can see demo repo is now an object in my home directory, and I can now change into it. And if I go to GitHub and I go to settings, it will show under SSH and GPG keys. Now it used to say never used. Now it says last used within the last week. It could have said last used within the last 10 seconds, but there we go, okay? So we have that. I have a demo repo now set up over here, and we can explore the contents of this folder. Let me just kind of make sure I'm following track here. Okay, so so we've created our remote repository, origin main. We use git clone. And this is going to kind of create my local repository. So now what I want to do is, let's say I want to make changes on my computer and I want to push them to GitHub. So I'm going to change into my folder demo_repo. Okay, so now I'm in my demonstration repository. I can type in ls. And I have just one file in here, readme.md, a markdown file, okay? You can always check to see if this is a repository by typing in git status, okay? And if you type in git status, it will give you some kind of answer if it's a Git repository. If I go to my home directory is not a GitHub repository. So if I'm in my Git home directory and if I type in git status, it's going to say not a Git repository. Okay, so that's fine. I'm going to go back to my demo repository. I type in git status. I can see I'm in my home. It is a Git repository. Okay, what I want to do is I want to say modify some of the files here. Okay, so I just have one file here. Let's create a file. Okay, so in Linux or Mac OS, there is a text editor called Nano. Okay, if you're on Windows, you can just kind of navigate to your folder and then just create files and stuff. Okay, but I'm going to just type in Nano, and Nano is the text editor, so I type in Nano, and then I'm going to create a file, and I'm going to just create the file name. So I'll just call this list.txt. Okay, so this is going to create a file called list.txt, and it just opens up a blank file, and I'm going to just write this is a list of things I like. Okay, all right. So number one, I like UCLA. All right. And number two, I like statistics. Okay. And three, puppies. Okay. So we will, this will be my list here, and we will save it. So to save, this is weird. On Nano, you hit Control-O, okay? It's like, why not Control-S? But Control-O is write out. What's the file name we want to write? List.txt. We're going to hit Enter. And I'm going to hit Control-X to exit. And so now I'm exited back to the directory. I'm going to type in ls. It shows me I have readme.md, list.txt. So this is a thing. And I want to see, all right, git status, okay? It says you have a file here, list.txt. This is an untracked file, okay? It recognizes that a new file has appeared here. So what I want to do is I want to commit this file to my repository. So I'm going to do git add list.txt. One nice thing about the terminal is you can start typing the name of a file. If it's a long file, you can hit tab and it will complete it. How many view quizzes answers have I given you? Just one. Okay, let me give you your second answer. Second answer is B. B as in bear. B is your second view quiz answer, B. Okay, so we're going to do git add list.txt. I'm going to hit enter here. Okay, I'm going to check git status. And now it says, hey, this file is ready to be committed, okay? Changes to be committed. So I'm going to go ahead and commit it. I'm going to do git commit -m. We have to put in a message describing my commit. I'm going to say created list.txt with 3 items. And I hit enter. So now, I just created a thing. It says, I don't know who you are. Okay, so so I have to configure this. So it didn't let me do that. Okay, so this is great. Because you probably have to do the same thing. So this is one thing about Git is sometimes its error messages are very helpful. And it says, you know what? I don't know who you are. You need to configure these things. So, and it tells you exactly what your commands are. So you're going to type in exactly what you see. Git config. For me, it's going to be global. My user email is going to be the account that I have, mileschen@ucla.edu. My git config global username is going to be mileschen. Okay. All right. So you have to configure your settings here. We'll create a user email and username here. So I've done that now. Now I can go ahead and commit it. Okay. So I will type in git commit -m created list.txt with 3 items. Okay, and so now I have committed this change, okay? All right, so now we will check git status. And it says nothing to commit working tree clean, but it says your branch is ahead of origin main by 1 commit. Okay, origin main is the remote repository that exists on GitHub. Okay, so right now if I go to GitHub and I refresh the page, it looks exactly the same as before. What I need to do is I need to tell my local computer to push the changes I've made, the commits I've made to GitHub. Okay, so that it will get updated. So so I'm going to just type in git push. Okay, I can type in git push origin main, but it's not necessary. I can just type in git push. Okay, and because I've set up my SSH key and everything, my computer is authorized to make changes to my GitHub repository. So I do git push. Now if I go to GitHub and I refresh the page, ta-da! List.txt now appears on my GitHub page. Okay, and I could see list.txt. This is a list of things I like: UCLA, statistics, and puppies. Okay, and that's how it goes. Now, let's say you're collaborating with somebody or something, and somebody makes changes here. So you can also make changes to files directly on GitHub. It's not the best place to do it, but in a pinch, if you need to make changes to a file, you can. So I can just click on, within GitHub, I can do edit this file. And I'll just add a 4th line. And I'll say, I don't know, what else do I like? Hamburgers, hats. Okay, and then I'll put in like things I don't like. Things I don't like. Mosquitoes. Okay. All right, so we'll do this. All right, so this will just be some changes I'm making to this file. I'm going to go ahead and I'm going to commit those changes. Commit message will be update list txt added things I don't like. Okay. All right, so we'll go ahead and commit changes, commit directly to the main branch. We'll go ahead and do that. Okay, so now this is updated on the repository. And over here, if I look over in my directory, okay, if I just say cat list.txt, it's still the old file. What I have to do is I have to fetch or pull the changes that exist on GitHub. Okay, so I need to pull those changes. So I'm going to do git pull, and I do that, and this is going to talk to GitHub and say, hey, do you have any changes that I need to do? And it does. It says, okay, list.txt added some lines. There were six lines added, I guess. Okay, and those get pulled now. And so I can look here, and I can see git status here, and it's now showing up there. I can do cat list.txt, and now it has the changes that I've made on GitHub. Okay, so all of the things that happen on GitHub and stuff now get pulled to my local repository here. All right, is that okay? All right, this is I need to show you another thing that you guys need to do. So on my professor account, okay, so I'm going to go to GitHub to SmilesChen. This is my account as the professor. So I'm logged in as a student. If I go to the professor's repositories, I'm going to go over to here, 2024 Spring Stats 21. And the way I'm going to post all the content is I'm going to post it on GitHub. I'm not going to post it to Brew and Learn, okay? And this will force you to use GitHub. And so what you need to do is you're going to need to fork this repository, okay? What a fork is it's like you're creating your own kind of branched timeline, okay? But you don't own the original thing, okay? Because me, the professor, owns this. You, the student, don't. So what you're going to do is you're going to fork this to your own account, okay? So I'm going to click fork, and I fork it, and it says, okay, 2024 Spring Stats 21, copy the main branch only, that's fine. I'm going to go ahead and click create fork. So it takes a few seconds. Okay, and so here is the thing, and it says it's forked from SmilesGen. And what we want to do is we want to clone this to our local computer. So I'm going to go to hit the green code button. I go to SSH. I'm going to copy this URL. Make sure you are back in your home directory or wherever you want to be, okay? So I can do something like cd tilde. You don't want to fork it inside. You don't want to create a repository inside a different repository. That's just going to create headaches, okay? So make sure you go back to a folder where you want to be, whether that's in your home directory, whether that's on the desktop, whether that's somewhere else. Navigate to the folder where you want it, okay? And you're going to do git clone, and you will paste that address, okay? This URL that you copied from the green button, okay? So this is your account. So on mine, it's GitHub MilesGen student, okay? It'll be for you GitHub whatever Joe Bruin 2024 SP Stats 21. You're gonna click this button. You're gonna copy that, and then you type in git space clone space paste that URL. Hit enter. It's gonna clone it, and now you have the clone of the repository, okay? So if I type in ls and ask what's there, now I have two folders. I've got the demo repository. I have my 2024 SP Stats 21, and so I can change into 2024 SP Stats, Spring Stats 21. And again, with tab completion, you can probably just type in 20 and hit tab, and it will probably autocomplete there. And so this is that. You can type in git status, and it says this. And what we need to do is we need to create something called an upstream repository. So I think, do I have this? So you need to create an upstream. And so the idea is, this is the professors, okay? Professor repository. And you've created this fork, right? This really feels like I'm drawing some time sequence here, okay? So you've created your fork, okay? This is your forked repository. And you're gonna be, you can be making commits and things like this, okay? Now, I'm gonna be adding files, okay? And you're gonna wanna kind of pull those down, okay? So you wanna be able to like pull those changes. So this, you're gonna have to pull, but you call this the upstream, right? When you fork it to GitHub, you have your origin, okay? So you fork it, this creates a copy on GitHub. This is your origin repository, and so whenever you do git pull and git push, that will generally talk to your origin repository. If you want to pull changes that I make, you need to set up my repository as an upstream repository, okay? Oh, I'm running out of time. So, so what you want to do is you want to add, okay, a remote repository. So one is you can check your configuration using git remote-v, and over here you go to SmilesGen's repository, okay? You're gonna copy this, the SSH for SmilesGen, okay? And it will say SmilesGen over here. And you're gonna do git remote add, and you need to add an upstream repository, and then you paste this. So everybody, when you add the remote upstream, it should say Smiles Chen, okay? And when you do that, now when you type in git remote v, -v for verbose, which tells you all of the remote repositories you have, you should have 4 things. One will be origin fetch, origin push, and upstream fetch and upstream push. The origin will have your username, okay? For the student, it's Miles Chen student, or whatever it is, Joe Bruin, okay? Everybody's upstream should say Smiles Chen, which corresponds to the professor's account, all right? And then, and I will show you how to make, how to pull those things, but basically, later on, you will pull changes from the upstream repository by doing git pull upstream main, and that will pull any kind of changes that I make in the upstream repository. Okay, I will give you your third view quiz answer, but I'm going to go ahead and stop the video here for those watching on the remotely on the video. Sorry, you'll miss out on the last view quiz answer. This is for those in person only. Okay.